So number 1, it says graph x cubed minus 9x on your calculator. So I'm going to go ahead and just put it on my calculator. I'm going to go x to the third power minus 9x. Okay, see it? I'm going to adjust the window a little bit because I kind of know what it looks like. I really do. I'm going to go negative 5 to 5. And I'm going to go probably negative 10 to 10. I know what it looks like. Okay, so let me graph it. Okay, so looking at this thing. Okay, real quick. Would this graph pass the horizontal line test? No. So it does not. Right? Do we agree? Does not have an inverse. Okay. So right off the bat, have an inverse. Josie? Yeah. So it will not pass the horizontal line test. Right?
What was your window, Mr. Davis?
There it is. I might make it a little taller too. I might go maybe negative 12 to 12. Right? I went negative 5 to 5. I just know what it looks like, so I knew a good window, right? Right? And I did my x cubed minus 9x squared. Okay, and I graph it, right? That's a better one, okay? And you can tell that if we're to take, marker and just go boom, fails, boom, fails, boom, fails. I mean, it is a function. The original is a function, yes. But it does not have an inverse, right? It's not one-to-one. Because this y value would correspond to this y value, which correspond to this y value. You do not have unique y values or unique x values. To be one-to-one, it's got to be unique x's and unique y's. Yes, Anne?
So it doesn't have an inverse because if you did do the inverse, then it wouldn't be a function.
Correct. In fact, its inverse would look something like this, believe it or not. Its inverse, and it looks something like this. Okay? Does that make sense? Okay, good, very good question.
It has an inverse, just not a null.
Right.
It doesn't pass.
So we can say right off the bat, in fact, I'm going to make a little sketch of it here on my graph. It goes through it, negative 3, 3, and 0. And it looks something like this, right? And so, we've done this graph. That's what makes this chapter a little bit more comfortable. We're going back to stuff we've seen before, right? Y fails the horizontal line test, okay? It is not 1 to 1, okay? 1 to 1 means every single y value. Here's a y value of 0, here's a y value of 0, here's a y value of 0. There's 3 y values of zeros, right? That you can't have that. Every y's got to be unique and every x has to be unique, okay? Now, we actually did this kind of together earlier when we graphed, so let's graph it again. And I'm going to use my pencil this time because I'm going to do some erasing when I get done. So I'm going to use my pencil, start at negative 4. 1, 2, 3, 4, right? Everybody agree it's a parabola? Everybody agree it's a parabola, right? 1, 1, 2, 4, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? 1, 1. Okay, there you go. Okay, and I'll wait for you, okay? Everybody draw that picture, okay? Because we're going to change it. Okay. Does it have an inverse? No, right? No. Same thing. It fails the horizontal line test. Okay, everybody okay with that? I mean, it's not going to work. Everybody agree? So, find its inverse equation. Well, we haven't done this yet. We're going to do this now. Okay? To find its inverse equation, what we do is we switch x and y's. Okay? So, this equation is really y equals x squared minus 4. Because f of x and y are the same thing, right? So the original equation is y equals x squared minus 4. What we did when we did our little activity to start with is we've switched all the points, right? Switched all the points. But a faster way to switch all the points is just switch the x and y's. Because when you switch the x and the y, you've switched them all. You with me? Switch my x variable and my y variable, you switch them all, right? So to find an inverse equation, let's switch. We're going to switch x and y variables, okay? So we're going to switch x and y variables, okay? Yeah,
How can you find the inverse equation if it doesn't have an inverse?
great question. Will you hang on to that, please? Really good question. I'm going to answer that, okay? I'm going to go blindly into this, Will, like I think I know what I'm doing, okay? So, let's make it x equals y squared minus 4. Okay, what did I do? What did I do?
You put a Y instead of the X.
Yeah, I just switched the x for the y and the y for x, right? That's all I did. Everybody good? Okay with that? So if you need to find an inverse equation, switch the variables. X becomes y, y becomes x. Okay, if there's more than one x, make them all y's. If there's more than one y, make them all x's. Does that make sense? Every x becomes y and every y becomes x. Now, could you solve for y? Could you solve for y? Okay, so now let's solve for y. Could I solve for y? Could I solve for y? How would I solve for y? Anybody remember? You guys know how to solve equations. Not yet. Close. Okay, let's bring over the 4 first. Okay, bring over the 4. Bring over the 4, you guys. Bring over the 4. So if I add the 4, bring over the 4, right? I'd have a x plus 4 equals y squared. Right? A little side work real quick. A little side work. Okay, a little side work. A little side work. Okay. Just totally different question. Okay, totally different question, right? Totally different question. A little side work. Everybody looking up here? Okay, how would you solve for x here?
Square root.
Okay, good. So what's x equal?
7.
52.
Smart Alex. I'm going to add a minute onto you. I'm going to add a minute just for being smarty pants. and
4.
there's two
Negative
answers. A negative 5. Remember? Do you remember two answers? Because negative 5 times negative 5 is a positive 25. And 5. So there's two answers, okay? So what am I going to do next? I'm going to square root this, right? But when I square root this, I get plus or minus the square root of x plus 4 equals y. Now, that's not an equation, that's two equations. That's not one equation, that's two equations. So, Will, you're right, it doesn't have an inverse, and it really doesn't have an inverse equation either. It has two equations. Now, you could graph this on the calculator, you really could. Want to see it? Just the heck, what the heck, let's just see it. You could graph clear square root of x plus 4. Let me change the window a little bit.
Keep it as x equals y squared minus 4, but you have to change it to plus or minus square root of x plus 4.
You got to get it to here. Let me change my window a lot.
What?
Okay, there you go. Okay. Can you see what I did? And if I did the negative square root of x plus 4, okay, what do I get? So it took two, well, you watching? It took two equations to graph its inverse, right? So the problem is, if it takes two equations, it can't be a function, right? And it's not. So now, highlight it. I want you to highlight this. Anybody have a highlighter?
I did.
I did too. Mine. Oh, here's mine. Highlight this. Highlight this. Okay. Now, hang in there, you guys. You promised me 15 minutes. I'm almost there.
8 seconds.
We're gonna do it.
Oh, wait.
But I'm gonna add on time if I can't do my job, right? So, Will. It says let's fix this function to have an inverse. So you know what I'm gonna do? Watch. 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 Watch.
Why, baby?
Okay.
Because then it doesn't have, it has to go on the line.
Aaron said it. Anna, when I erase the back half, will it pass the horizontal line test now? Yeah. But you just can't do that. This is math. You got to have a reason. You got to have a rule. So it says change the domain. Now the domain has to do with x's, right? So I changed the domain. What I did is I said, whoa, 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 whoa. Let's name the domain now as x is greater than or equal to 0. And if that's all, if I change my domain, if I do this thing right here, then all I do is graph the front half of the graph. And now all of a sudden, it has an inverse. Its inverse is here.
Can you do,
That's f inverse of x. And it has an inverse, doesn't it? But I had to change it. I had to get rid of part of it for it to work. Okay?
can you do x less than or equal to?
Yes. Yes, and you would be completely right. Then we'd erase the front half and just have the back half, right? We normally don't, but you're completely correct, Aaron. Normally we take the positive value. But if you ever did the other way on a quiz, absolutely, I would take it, okay? We keep the positive values because most of our applications are with positive values, right? Okay, now, graph the new function. I did. There it is. There's my new. Now, how did I get that so quick? How did I graph that so quick? Well, I knew this point was at -4, didn't I? So its inverse had to be at -4. I knew this point was at 1, -3, so I knew this point had to be at -3, 1. I knew this point was at 2, 0, so I knew this point had to be at 0, 2, right? And I just graphed it in. Okay, ready to turn the page? I've got 4.5 minutes, okay? Now, old stuff, one more time, right? One more, okay? Now, let's put g of x, you ready? So let's put g of x. G of x is this, and let's put it into f. So it's going to go right in there, okay? So it's going to be 2 parentheses, 1/2 x, right? Minus 4 plus 4. So I took this entire equation, put it there. Took the whole equation, put it there. You guys okay with that? Took this whole entire equation, put it right there. Because g is inside of f now, okay? So g is now inside of f, right? Now if I simplify this, let's see what I get. I'm going to get an x minus 8 plus 4, okay? Or I get an x minus 4, okay? Now let's do the other one. Let's put f of x into g of x. It's going to go right there, right? So I'm going to have a 1/2 times a 2x plus 4 minus a 4, right? Am I going too fast? So I took all of this and plugged it into there. So I've got now f is inside of g. Don't say that too fast. I know you would like to say this fast. I get an x plus 2 minus 4 and an x minus 2, okay? There we go.
Ow, I hit my.
Am I done? Okay, homework. Let's change it to odds.
Go back up.
Let's change it to odds because it's hot and we're tired. Hey, and I got it done before 15 minutes, didn't I?
What do you mean?
There's our homework, okay? I changed it to odds. Yeah.